Alright, welcome back. Today we're starting our Chapter 2 lessons, and we are looking at solving one-step equations with one variable. So first, let's just look at a quick definition. An equation is a mathematical sentence where two expressions are equal. And the solution of an equation is a value of the variable that makes the equation true. And to find solutions, we're going to isolate the variable, and that happens when the variable appears by itself on one side of an equation, and it's not at all on the other side. We isolate a variable by using opposite or inverse operations. Which undo operations on the variable. And an equation is like a balance scale, and to keep the balance we have to perform the same operation on both sides. So if it's a balanced scale, it looks something like this. Because if I put a block on this side, I have to put a block on the other side. So you want to make sure that we're doing the same thing to both sides in order to keep the equation balanced. Examples of inverse operations would be, for example, additions. Inverse would be subtraction, because if I add something, I can undo it by subtracting. Same thing if I see subtraction, I can undo or do the inverse, which is addition. Now let's look at some situations where we can actually solve the equation. I always like to start with what's our variable. So in this case it's y, and now what's happening to our variable? Well, on this problem we have y minus 8. So the inverse, or to undo the subtraction, would be to add 8. But if I add 8 to one side, I have to add 8 to the other side. Minus 8 and plus 8 are inverse operations. They make a zero pair, they cancel each other out, leaving us with just y on the left side. And now we do 24 plus 8, which would be 32. Now the nice thing about equations is we can always check our work. We can take the original problem, y plus 8 equals 24, substitute in our value for y, which in this case was 32. Oops, no, it wasn't plus 8, it was minus 8. Equals 24. 32 minus 8 is 24. This is true, so my answer is 32. Let's look at another one. So here we have n by itself. What's happening to n? We're subtracting 3.2. Sometimes it's helpful to draw a line down our equal sign, so we're looking at that balanced scale, both sides. Since I'm subtracting 3 2/10, I'm going to do the inverse, which would be to add. These make a zero pair, they're going to cancel out, leaving you with just n on the left side. And now I have 5 6/10 plus 3 2/10, which gives us 8 8/10. Once again, you can go ahead and check that. So I could take 8 8/10 minus 3 2/10, which is going to give me 5 6/10. So that checks out as well. So let's look at another example. In this example, we have m plus 17. So since we see addition as our problem, the inverse operation would be to subtract 17 from both sides. Inverse operations are going to cancel each other out. We're left with m. Now if you look on the right side of the equation, though, we have two negatives. So negative 33 minus 17, remember we could rewrite as negative 33 plus a negative 17. So we're actually adding these numbers together. So when we do 33 plus 17, we're actually going to get 50, but since they're both negative, it would be negative 50. Alright, so why don't you pause the video and try this next one on your own. Alright, so here we have t on the right side of the equation. 1 8/10 is being added, so I'm going to subtract 1 8/10 from the right side. But if I subtract 1 8/10 from the right side, I have to subtract it from the left. And now we're going to do our problem. So if we have 4 and 2/10 minus 1 and 8/10, we get 2 and 4/10. And like I said before, you can always check your video to make sure, or check your answers to make sure that they are working correctly. So let's look at another couple of examples. You can try these on your own if you want. Our first example has D as the variable, and we're adding 1/2. So the inverse operation would be to subtract 1/2 from both sides. These two will cancel out, and we have D equals 1/2. Now the next one's a little bit different. If we look at it, x is our variable. Now here we have x plus -11. So our inverse operation would be to subtract, but because adding -11 is like subtracting, we're actually going to add the opposite, which is just going to be add 11 to both sides. Because what we want to do is undo or give the additive inverse to make that zero pair. So now it's going to be x equals 44. And remember, we can always check this by saying -11 plus 44 equals 33. And then we'd have 33 equals 33, which checks out. Now let's look at a real-life example. Over 20 years, the population of a town decreased by 275 people to a population of 850. We want to write and solve an equation to find the original population. So since we're finding the original population, that is going to be our variable. So our original population is going to be P minus the decrease in population. So in this case, decrease by 275 is, always means equal, the current population, which is 850. So now we're going to go ahead and solve this. P is our variable, so since it's minus 275, I'm going to add 275 to both sides. So the original population was equal to 1,125 people. If we look at properties of equality, there first is the addition property of equality, which says that you can add the same number to both sides of an equation and the statement will still be true. So for example, we know that 3 equals 3, so as long as I add the same number to both sides, my equation will remain true. Same thing with variables. If A is equal to B, if I add the same value to both sides, it remains true. And this is also true for subtraction. So you can subtract the same number from both sides of an equation and the statement will still be true. So if we start with 7 and if I subtract 5 from both sides, we have 2. If we start with A equals B and subtract C from both sides, it will still be true.